So now that we talked a bit about how streams are constructed, basically using an internal data structure, which is effectively a linked list of nodes corresponding to the source and all the intermediate operations that occur in a stream, let's go ahead and talk about the execution phase. And this, of course, is what's going to take place when the terminal operation is reached and all the actual processing begins in earnest. So when a terminal operation runs, the stream framework will then go ahead and pick an execution plan. And this is also described in the article at the bottom of the page by Brian Getz, where he talks about the way in which things work under the hood. I think the name of the article is like Java Streams Under the Hood or something like that. And as you'll see, there's a lot of different options that the stream framework can use. And over time, as you also might imagine, people keep getting more and more clever when they implement the streams framework to make it more optimized and more efficient and more scalable and more streamlined and so on and so forth. The particular plan that's picked to execute the stream is dependent on or is based upon the properties of the source and the aggregate operations that make up the stream, make up that internal linked list we were talking about before. Intermediate operations are divided into two categories, and this will affect the plan by which the stream will be run. Some operations, as you may recall, are stateless. So those include operations like filter, map, flat map, and so on. If you have a stream, a pipeline of intermediate operations that only have stateless behavior, the semantics are only stateless, then that stream can run in a single pass, even if it's a parallel stream. So you can basically have this thing just run, the elements will be pulled through from the beginning, run through each of the intermediate operations, and then the terminal operation will determine what happens to them next. They'll be collected together into an array list or whatever. So stateless operations can be run in one fell swoop, very optimal, very efficient, no need for additional memory, no need for additional buffering, no need for additional processing phases, and so on and so forth. And that's why it's typically desirable, if you can, to try to use stateless operations. In contrast, if you have streams that contain stateful operations, things like sorted, limit, distinct, drop while, and so on, then those operations are divided up into sections, or the stream pipeline that contains stateful operations is divided up into sections and run in multiple passes. And the reason for that, of course, is that the different passes have to reflect the different states. A simple example would be sorted. You're obviously not going to be able to process all the elements through sorted until you've collected them all up into an intermediate buffer. And then you can only have the sorted operation occur after all the other intermediate operations up to that point have finished whatever they're doing. So you can't do it in a single pass. You have to go ahead and do all the other intermediate operations before sorted, store the results into a buffer, then apply the sorting mechanism based on either ascending or descending or whatever the way in which you do the sorting comparison will be. And then after that, then you can go ahead and keep doing the next phase of processing with subsequent intermediate operations or the terminal operation after you've finished the results of sorting the intermediate operations up to that point. So you can see here that that's going to get more complicated, and not surprisingly, it's going to take more resources because you have to buffer these things, you have to keep track of the state, and you can only do the operations when you're done with the previous ones. So not surprisingly, stateful operations take more resources to run. Terminal operations are also divided up into two categories. There are the run to completion operations, which would include things like reduce, collect, for each, and so on. And these operations process the data in bulk using a method on the splitterator called for each remaining. And what for each remaining does, as the name sort of implies, is that for every element that's in the splitterator at that point, it'll go ahead and run some action on each element. And it's a run to completion model. So unless an exception is thrown, every element will be processed. And that is pretty much what you need for reduce, collect, and for each. In contrast, if there are short circuiting operations like any, match, find first, find any, none match, those kinds of good things, they have to process the stream, the terminal operation has to process the stream one element at a time, because it could be that any given point, you now know that you're going to bail out because either your condition was met or your condition was not met, and that's a trigger that you're done. So what they use internally is they use the split iterator try advance method as opposed to using the split iterator for each remaining method. So just little different behaviors. Obviously, all this stuff is handled under the hood by the streams framework, but it's useful to understand the difference between run to completion, which uses for each remaining, and the short circuiting approaches, which use try advance. So again, different pros and cons in each of these approaches, but they give you the right semantics. So that's the end of the overview of the execution phase in Java Streams, which, as we can see here, is triggered when the terminal operation is reached. Note that our focus on internals up to this point has exclusively been focusing on sequential streams. We'll talk about the way the parallel streams work later, and they're very, very interesting. The split iterator works different, the apply phase works different, and of course the combine phase will also work different for parallel streams, and it'll work in a much more interesting way, as you'll see when we get to that part of the course.